Hi class. So we're starting our first lesson in chapter 6. So we are slowly getting through the year. We're slowly getting through the content. So what I want you guys to focus on today is if you can apply your knowledge of percent composition. So that's what I'm going to be teaching you about today. And then all these three are going to happen once we learn about percent composition. So if you notice, water always comes as H2O. Hydrogen peroxide is very similar to water. It's H2O2, but it's not water. Okay, and not only are they different molecules, they have different physical, they have different chemical properties. They're two very, very different chemical entities. And the reason why we always know water is H2O and hydrogen peroxide is always H2O2, it has to do with the law of definite proportions. So let's think about, or I'm going to give you what the definition of the law of definite proportion is, that a given chemical compound always contains its elements in a fixed ratio Okay, so what that means is that if you have H2O, that it's always going to be 2 hydrogens to 1 oxygen. H2O2 is going to be 2 hydrogens to 2 oxygens. Something like carbon dioxide is always going to be 1 carbon to 2 oxygens. What about something like, I'm going to just move down over here, something like C6H12O6. Hopefully you guys remember from grade 9 proportions that if you have 6 carbon to 12 hydrogens to 6 oxygen, that you can actually reduce it. 1 carbon to 2 hydrogens to 1 oxygen. Okay, so while none of these formulas are reducible, this one down here it is. Okay, and this comes into play when this is glucose here, but sucrose is very similar, C5H10O5. And if you look at the proportions, they're all divisible by 5. 1 carbon to 2 hydrogens to 1 oxygen. Guess what? Their proportions, their ratios are exactly the same. And so I will teach you later on in this unit what we do with these types of problems. How we can further identify sucrose from glucose. Okay, let's look at an example here. A compound with a mass of 48.72 grams is found to contain 32.69 grams of zinc and 16.03 grams of sulfur. What is the percent composition of the compound? So this question here isn't asking to know what the formula is, to not know what the proportions are, but they're asking to find out what percentage is zinc and which percentage is sulfur, because we use these percentages to find the proportions that molecules and formula units are in. Okay, so let's put down that what we have. We have the total mass, which is 48.72 grams. We have the mass of zinc, which is 32.69 grams. We have the mass of sulfur, which is 16.03 grams. Now think about how you calculate your mark on a test. Let's look at zinc, and let's think about how we're going to calculate zinc's mark. Well, on the test total, there is 48.72 questions, and zinc got 32.69 questions correct. Okay, this is how you calculate your mark on a test. It kind of works with this. Basically, what you're going to do is you're going to take the proportion of what you want to calculate the percentage of, and you're dividing it by the total here. Okay, so let's get our calculator. 32.69 divided by 48.72 times 100 equals 67.10%. So I'm keeping significant digits. There's 4 significant digits and everything. Now, if I want to find the percent of sulfur, there's 2 ways you can do it. You can either do 100 minus 67.10, or let's do the math way, just because this is our first time learning it. And I'll show you something else too. If we have 16.03 grams divided by 48.72 grams, and I multiply it by 100%, do you see how these grams cancel out? So the percentage is always, or sorry, the unit is always percent. Okay, so 16.03 divided by 48.72. Oh, we have a little drama in the house right now. I get 32.90%. And if you add those two together, guess what? It adds to 100%. Okay, now we're going to look at finding the percentage composition from a chemical formula. So cinnamaldehyde, C9H8O1, so C9H8O. That's what's responsible for giving cinnamon its odor. I love the smell of cinnamon, especially during winter. Okay, so determine the percentage composition by calculating the mass percents of carbon, hydrogen, and oxygen. All right, so all that was given to us was the formula. So the first thing we are going to do is find the molar mass of cinnamaldehyde. So we're going to do 9 times 12.01 for carbon, and I leave my calculations unitless until the end, otherwise you're just writing so much, times 8.01, or sorry, times plus 8 times 1.01 plus 16.0. Okay, let's do this on our calculator. I get 132.17 grams per mole. Great. Okay, so now that I have this is now the total molar mass. I'm not working with masses anymore. Now I'm working with just molar masses. Okay, I'm going to use a different color for carbon. So if I want to find the percent of carbon, I have to, this is going to be my numerator, 132.17 grams per mole. And how much carbon do we have? We had 9 times 12.01, and I get 108.09 grams per mole times 100%. Now, because this is grams per mole and this is grams per mole, oh, you can't see that, these cancel out. So it doesn't matter whether we're using grams or we're using grams per mole, as long as they both match. Okay, so if I divide that 132.17, I get 81.78% as my percent carbon. Okay, now my percent hydrogen. I have 8 of them, so 8.08 grams per mole divided by 132.17 grams per mole times 100%. And I get 6.1 0.13%. And I'm just keeping it to four significant digits here. So even though there is, okay, let's see, there's 9 carbon and then there's 8 hydrogen. 9 carbon represents 82% of the mass, and 8 hydrogen represents just over 6% of the mass. And it's because hydrogen atoms weigh so much less. And then looking at just 1 oxygen, just that 1 oxygen represents 12.11% of the mass composition of cinnamaldehyde. Okay, and so this is all because of the different molar masses or the different masses of the elements. Oxygen is the heaviest, and so just 1 atom is going to represent 12% of the mass. Okay, so there's some example questions there for you to do as well. And I think that's it. Right. So hopefully that makes sense. This is a pretty easy concept. It does get a little bit more difficult, so make sure that you have a good grasp of this before you move on.